In this video, I'm going to talk about percent composition and how to calculate that. So percent composition is just asking you, for example, how much of the mass of water, of a water molecule, is taken up by the oxygen. Like the oxygen provides how much, what percent of the mass. And you can ask this about any element in a compound or all the elements in a compound if you want to. So here's an example question. Let's say we are asked to find the percent composition of barium in barium nitrate. So the first thing we have to do is determine the mass of the whole thing, barium nitrate. So you can think about this. There's 3 oxygens on 1 nitrogen, and there's 2 NO3 groups. So it's basically Ba, NO3, and another NO3, because there's 2 NO3 groups. And if we add all this up, we have 1 barium plus 2 nitrogens plus 6 oxygens. So we look up the mass of each one. Barium is 137.33. Nitrogen is 14.01. And oxygen is 16.00. We're going to add all those up, which equals 261.35 grams per mole of BaNO3 2. We're asked just to find what percent of this 261 grams is taken up by the Ba. So to figure out our percent composition of Ba, what we do is we take the number of Ba's divided by the whole mass of the whole compound times 100. So we already looked up Ba. It was 137.33. The mass of the whole compound is 261.35 times 100 is 52.55%. So a little over half the mass of this compound is taken up by this one atom, the barium, because the barium was so heavy compared to the nitrogen and the oxygen. All right, let's say that for our second problem, that instead of the barium, let's say we're asked for the percent composition of the nitrogen. Again, we want to take the number of nitrogens times their mass over the total mass times 100. So we have 2 nitrogens. Remember, this 2 distributes in. So we have 2 nitrogens, and each nitrogen is 14.01 grams per mole. And our total mass is still 261.35. And then we multiply by 100 to turn it into a percent. So we're going to have 28.02, which is 2 times 14, divided by 261.35, which gives us 10.72% nitrogen. So this compound is a little over 10% of the mass is due to the nitrogen. If we were asked for the oxygen, the way that we would change this, if we're trying to find oxygen, is we would need to change this to the number of oxygens times its mass. We have 2 times 3 is 6 oxygens, and the mass of each oxygen is 16. The mass of the whole thing stays the same, and our times 100 stays the same. So we have 6 times 16 divided by 261.35 times 100. So that is 36.73%. And you can do that for any element in any compound. I'm going to do one or two more. You may want to pause the video, work them out, and see if you get the same answer. Let's start with a new compound. K2SO4. And let's say we are asked for the percent composition of sulfur in potassium sulfate. So the way that we do this is we're going to take our mass of our sulfur. So we look up sulfur on the periodic table is 32.07 grams per mole, and we only have one of them, so we don't have to multiply it by anything. On the bottom, we have to have our total mass, so we need 2 Ks, and potassium, which is K, is 39.10 plus 1 sulfur, which is 32.07 plus 4 oxygens, which are 16. So on top, we still have 32.07. Remember, we're going to have to multiply this by 100. On the bottom, 174.27. So we're going to take 32.07 divided by 174.27, and we get, times 100, we get 18.40% sulfur in that compound. Let's make it as hard as possible. Let's use magnesium phosphate. So for this example, we are going to determine the percent composition of magnesium in magnesium phosphate. So we're going to need the total mass, and we're going to need the mass of magnesium. So on top, we want the mass of the thing we're trying to find, which is magnesium. So we have 3 magnesium atoms, and magnesium is 24.30 grams per mole. On the bottom, we need the total mass. So we have 3 magnesiums plus we have 2 phosphates, and phosphorus is 2 phosphorus. Phosphorus is 30.97 plus 2 times 4 is 8 oxygen, which is 16. This is going to be 72.9 divided by 262.84 times 100, which is 27.74% mg. If you were asked for example oxygen, then you would put the mass of 8 oxygens on top, and the bottom would stay the same. I hope this has helped. Please watch other videos if you need help with other concepts, and like and subscribe. Have a great day.